that the function on the bottom, it is assumed, cannot equal 0. Okay, so this is what a rational function is going to look like. So let's talk about our 12 basic functions. Remember how I had you memorize those earlier in the year? What is the most basic rational function? What do you think? Y equals what? But that would be the most basic linear function. Y equals x because it's a line. Y equals, that's your most basic parabola or quadratic. The only one that was a fraction, or the most basic one, I shouldn't say the only one, was y equals 1 over x. Okay, and so all of these really come from the basic function f of x equals 1 over x. And just to refresh our memories then, a little sketch of that is, looked something like that. Okay, so when we talk about the basic function f of x equals 1 over x, what are the horizontal and vertical asymptotes of that? The vertical would be the line x equals 0, or we could say it's the y-axis, right? And what about the horizontal?
0, 0.
Also y equals 0 instead of x equals 0, okay? And so today we're going to see some things that have asymptotes, but they're going to be related to this. So I'm going to get into how you can figure out how they're all related to 1 over x using a transformation. But first, I want to explain how we describe the behavior around an asymptote. So let's take a pretty simple one, and the function I'm going to give you is f of x equals 1 over x minus 2. We are going to use limits to describe the behavior around the vertical asymptote. So I'm going to leave some space for that. And related to that, leave some space for that, we're also going to find what the domain is of the function, because the vertical asymptotes happen at the values that are not in the domain. Okay, so first we'll start with this, because you should know how to do the domain already. Just in your own words, what's the domain of this function? In other words, what can x be? What can x be? Yes?
All numbers is the 2.
Yes, all real numbers except x cannot equal 2. And so we have different ways we've written that, right? I'm going to choose to write that in interval notation. So you don't have to write it in interval notation. In interval notation, that would be negative infinity to 2 and a parentheses, because the function actually does not reach 2, and then 2 to infinity. And so I'm going to just give us a visual. We want to be real careful in this lesson today that when you're putting things on the bottom of a fraction that you use a parentheses when you're using your graphing calculator, because otherwise your calculator will just divide the first thing. So if I was to do that, so we see that, right? Okay? So negative infinity to 2, it's like there's two parts of the graph. Negative infinity to 2, and then 2 to infinity. Or all real numbers not equal to 2. So what that means is there's a vertical asymptote. Where is the vertical asymptote? At 2. And so we have this new thing. We've done end behavior before, but we have a way of describing the graph as it approaches the asymptote. So let me first sketch the picture here. So here's 2. And it doesn't show up on the graph, but I'm going to write a dotted line there. That's where the asymptote is. Okay, so we look at the asymptote from both sides. Coming from this direction is the right. Do you see how that's the right of the asymptote? Okay. And coming from this direction is the left. So the way that we write that, instead of writing out the word from the right, is we have a little notation. So we're going to write the limit as x goes to 2, because that's what it's approaching. From the right, what we do is we put a little plus sign behind it. Not in front of it, behind it. And that means as x approaches 2 from the right. The little plus sign just means from the right. How do you think we write from the left? We write x approaches 2 and we put a little negative behind it. Now, at this point, you should be able to do that with your notes, but you don't have to, on an assessment, I will write this out for you. You just need to know what it means, okay? So what do you think? As the function is, now this is different, because before we were going to the end, now we're coming in. What's the function doing as it approaches 2 from the right? It's going up or down? Up. So we are going to write f of x equals infinity. Okay, how about from the left? Going down, so it's going, f of x is going to negative infinity. Okay, so that's how we describe the behavior around asymptotes. We do it from both sides and we use that little notation. Okay, just a quick note, we're going to spend way more time with this tomorrow, but what is the function doing now as it goes to infinity? It's not going up and down anymore. It's approaching what? 0. And we call that an end behavior asymptote. It's actually a horizontal asymptote at y equals 0. Okay. And so we'll get into how from the function we can tell that. All right. So the second thing that I want to do with you today is just show you how you can do or how you can relate rational functions back to 1 over x. So we are going to describe how f of x equals 1 over x can be transformed into, and I'm going to give us 2 of them. The first function we're going to look at is g of x equals 2 over x plus 3 and the second one is not going to be as obvious, so we have to use something from our previous lesson. It's going to be 3x minus 7 over x minus 2. So let's think of our transformations. Remember, we're comparing it to this function. So we want to think about what happened. And one of them I think you can see. Look at the x on the bottom. What is it replaced with? X plus 3. How does that move the function? So it's moved 3 to the left, okay? So to see the other one, I'm going to do something. I'm going to do 2 times parentheses 1 over x plus 3. Because if there is a number on top, that is the same as the number being in front. Because 2 is the number 2 over 1. So the number in front would be moved to the numerator. So if you see it written that way, can you tell me what the second transformation is? The function's multiplied by 2. So what transformation is that? Good, a vertical stretch of 2. So let's write our 2 transformations down. We have a vertical stretch of 2. And then a shift 3 units left. I'm going to just put 1 over x in my y1, and then I'm going to do 2 divided by x plus 3, and hopefully you'll be able to see that. Okay, so there's 1 over x. Okay, and so it's hard to see the stretch, but you could definitely see the shift 3 units to the left, right? And all a stretch is going to do is really, it's going to make these parts around the asymptote grow quicker, so they're going to get steeper quicker. So you can see that this looks a little steeper than 1 over x. Questions so far? All right, what about this next one? I mean, we see this x minus 2 here, right? So we're thinking it's 2 to the right, but we have a lot going on up here. So I'm going to show you when there is an actual function on top. What we do is we go back to 2, 3, I think it is. It was 2, 4. I am going to write the division out, and then you're going to be able to see the transformation. And by division, I mean, this means that 3x minus 7 is divided by x minus 2. And so what we're going to be able to see is this written as a remainder. That's where it becomes important. So, x times what gives me 3x? 3. 3 times x minus 2 means 3x, and 3 times negative 2 means minus 6. And I'm going to subtract to find the remainder. So 3x minus 3x is 0. This really means negative 7 plus 6, doesn't it? So it's a negative 1. Okay. Now it's important that we write, so the division, when I divided this, I got 3 plus a remainder of negative 1. Do you remember how I could write this as a fraction over what I divided by? And so when I do that, then I can see the transformation. Okay. This plus 3, I can move it to the back. So I have negative 1 over x minus 2 plus 3. All right, looks like there's 3 transformations here. What does a negative out in front of a function mean? Flipped over the x-axis. So one of my transformations is a reflection over the x-axis. On the bottom was an x, and now it's an x minus 2. How does that move a function if I replace x with x minus 2? It's shifted 2 units to the right. And it's also shifted plus 3, which means up 3, because it's after the function. Alright, and so I'm going to put it in its original form so you can see that these are identical. We just wrote it as a quotient instead. Because a division bar and a fraction bar are the same thing. So in its original, it was a 3x minus 7 on top. And it's x minus 2 on the bottom. Alright, so hopefully you can see that these were over here and then they flipped. So this went the other way. There's my 2 to the right, and you can see that instead of an asymptote at 0, it's now at 3. Okay? Questions so far on that?